Hey guys, welcome to the tutorial on eigenvalues and eigenvectors. In this video, we'll talk about how to calculate eigenvalues and eigenvectors, what are eigenvalues and eigenvectors, and then we'll see how to calculate eigenvalues and eigenvectors using Python for a particular matrix. Whenever we are working on a huge data sets, that means a large sparse matrix, and it can take up a significant amount of space on the disk. Plus, it becomes extremely time consuming for the model to train itself on the data. And it has become difficult to visualize the data with more than 3 dimensions, let alone the data set of over 100 plus dimensions. So we need a way in to compress or transform the data into a smaller data set. The solution to this is to utilize eigenvalues and eigenvectors for the matrix to reduce the dimension space. Now let's say we have a vector V and a matrix A. We can use A as a transformation matrix for vector V. Which gives us this transformed vector as a result. Now note that the transformation has affected the length of the original vector but not in its direction. In other words, it simply scaled a vector exactly as a scalar multiplication of 2 would do. Now when we have a transformation like this in which a matrix transformation of a vector can be performed using a scalar multiplication, we write the equivalent like this, which is the Greek letter lambda used to indicate the scalar multiplier. The scalar multiplier is known as the eigenvalue of a matrix A and the vector as its corresponding eigenvector. Now a matrix generally has more than one eigenvalue and one eigenvector pair. Now for any given matrix, you can represent its eigenvectors as a matrix with an eigenvector in each column. Okay then, now let's jump into our Jupyter notebooks and see how it's done in Python. Like always, we'll import NumPy and create a 2 by 2 matrix of which we will calculate the eigenvalues and eigenvectors. Now NumPy provides us with a linear algebra module and we will use linear algebra module to find out the eigenvalues and eigenvectors of this particular matrix. Now, as we have discussed before, for any given matrix, you can represent its eigenvectors as a matrix with each eigenvector for each column. We get a similar result here. Now, we also have provided multiple exercises for you to try on your own by using the knowledge that you just gained about matrices. So, guys, this was all about eigenvalues and eigenvectors. We'll meet again in our next video.